Miss Mo. This is the test review for test 2. I actually already made the videos, but I deleted all of them except for the last one somehow, so we're doing this again. Alright, it says name 2 arrays that contain the following line segments. Okay, array starts at a dot and it ends at an arrow. Okay, and let's say this array is called A, B, C. Okay, then I could say that this line segment AB is up on this array, or I could say the line segment BC is up on this array. I think you get the point. Or I could say that AC is up on this array. Okay, so I think you get the point. The question is asking, give me the array, like the point to the arrow, that contains NQ. Okay, so let's find NQ. NQ is this little smidgen right here. Okay, and then these arrays have to include NQ. So, if we look at PU, let's trace where PU is. PU is this guy. Is that little orange segment on that blue? Nope, so that's out. Then let's look at MS. I'll look at the very bottom one. MS. MS is right here. And is the orange on top of that? Nope. What about TQ? TQ is this little middle segment. And is the orange overlapped on that? Nope. But let's look at NQ. NQ looks like NQ looks like that's NQ, and it's talking about the array, so it goes on forever. And it's asking, is the line segment NQ on this array? Well, heck yes, NQ is on this array, because this little bitty portion of the line segment is on that whole thing. So B is definitely correct. Let's look at RQ. Where's RQ? RQ is the whole thing from the top all the way to the bottom. And it looks like NQ is right on a piece of it. See, this NQ is on top of this whole RQ. So that's also the answer. Alright, let's keep looking. The next one says select 2 arrays that contain ST. Okay, where's ST? ST is over here. So the only array that could contain this line segment is the arrays made from these letters. Okay, so let's see, RU, that's from the top all the way down here. So RU is from here to here, this orange. And the question is this little pink, this little purple portion part of that orange? And yes, it is. Okay, UP looks like here to here. And that does not include this little pink portion that we were looking for. MT is from the very end, the very left, all the way to the center. But it doesn't have that little line segment on it, so it's out. SN. S is from here to the left, but it will not include that little line segment. Whereas SU, let's see, what's S? S is here, U is all the way to the end, and that little line segment sits inside. Okay, so basically it's asking which one of these arrays has NQ or ST on it, exactly on it, sitting on top of it. Alright, let's look at the next sucker. It says, what is the intersection of AB and CE? Okay, well, here's my little prism thing, pyramid looking thing. Yeah, okay. It's kind of a bad picture, but good enough. Alright, and it's asking, what's the intersection of AB and CE? Okay, AB, that's here to here. And where's CE? CE is this back right point all the way to the top. Okay, so it's asking, where do those two touch? And those two don't even touch each other. We have a front edge and a back side edge. Those are never going to touch each other. So the intersection is no solution, or 0 with a cross through it. Alright, let's try the next one. I'm trying to make it look like it was drawn, but I'm not doing a very good job. Okay. Woo. Okay, it says, what is the intersection of planes ADE? Okay, well, let's come up with the planes. ADE. ADE. Okay, ADE looks like this side triangle, the left-hand piece. Okay, let's see, BCE. BCE is this right-hand side of the prism. Then it says ABC. This one's a little tricky. A, B, C creates a triangle along the bottom. Okay, so it's asking, when does this yellow triangle on the left side, this right blue triangle on the right side, and this green triangle along the base, where do they all touch at the same spot? And the answer is they never touch at the same spot. So it's no solution. Now, I know this blue and this yellow touch, and I know the green and the blue touch, but we want all of them to meet at some point. Okay, let's look at part C. Alright, part C says, what is the intersection of AD? Let's find where AD is. Only this time it has arrows on it, opposed to part A, which just had a little line segment. That little dash on top just means from one point to another. On part C, those arrows mean technically this goes on forever. Yeah, so that's AD. Now let me look at AB. AB is right here. So it's from A to B, but they go on forever. And it says, what is the intersection? Where? Well, where do these two cross? Or where do they touch? And they touch at point A. Okay, next sucker. Okay, it says, which pair of lines are skew lines? Skew lines mean they never touch and they're not on the same plane. Okay, so let's look at AB and CD. AB is right here. CD is back here. Okay, and the question is, which part are skew lines? Well, skew lines cannot be on the same plane. So this AB and DC, those are not skew lines because they're on the same plane. They're both on that base That parallel crooked rectangle looking thing? Yeah. Let's look at AD and BC. Okay, AD are these guys. Okay, BC is this guy. Okay, so they're not on the same plane, check. But, I mean, skew lines are not supposed to be on the same plane. But if we look at these orange lines, those orange lines look like they're on that base, and they are. So, part B is not skew lines because the two lines that we drew were on the same shape, that same base, that same plane. Okay, let's look at part D. Part D says CE, that's like up here, and BE, that's right here. And again, those are on the same plane, so it's not D. Let's look at what actual skew lines look like. AD and CE. AD is this left piece. CE is this back side right piece. And those suckers are not on the same picture. This AD is either on this left triangle or the bottom base. This CE is either on the right triangle or on the back triangle. But either way, they're not on the same base. So, C's the answer. Alright, let's look at E. Parallel. Okay, parallel means they never touch. Whatever direction they're going, they never touch. So, let's see. Okay, my picture's kind of poopy, but whatever. Okay, it says AD and AB. AD are here, AB are here. Those are not parallel, those are touching. Okay, BE. BE is this sucker, AD is this sucker. Those are not parallel. Part C. AD is this sucker, this yellow one. CE is this back guy. Those are not parallel. Whereas if you look at AD and BC, these two suckers are for sure parallel. Alright, let's see, it says find a plane not determined by one of the triangular faces or the base. Choose the correct answer below. Okay, so we're going to see which one of these letter combinations creates a plane that's not the base, like this rhombus, parallelogram, rectangle looking thing on the bottom, square, yeah, or these triangles from the sides. So let's start tracing. BAD, that looks like this. This is BAD, but it says find a plane not determined by one of the triangle faces or by the base. Well, that BAD is on the base, so we don't want that one. Let's look at CED. CED is this back triangle, and we were told to pick something that's not on the triangles. Lastly, we have AEC. AEC means bottom left, up to top. Okay, AEC is actually this triangle that's created when we cut through the side of it. Yeah. So it's kind of like we have a triangle standing up. And that is not on the base or a triangle that we already have. So this triangle that's standing up, it's standing up in the middle. Front to back, it cuts down the middle, and it does not lay on top of these back triangles. Alright, let's keep going. Convex and concave. The way I remember convex and concave is concave is like this person, but let's say this person gets punched in the face and they look like okay, that now, because their face gets punched in. Yeah, that means convex. So when you can take a side and you push it in, it means convex. I mean concave. I had those backwards. So convex is any kind of shape. But then concave is what it would look like if maybe you punched it with your hand. It would cave in. Okay, so let's look at this. This sucker's a convex, but if I were to maybe I punched this piece with my hand, and it kicked it back in, that would be concave because it would get caved in. But this one isn't caved in. All the points are poking out, 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 so it's convex. Whereas if you look at this picture, it got caved in. On the bottom left and the right, so it's called concave. The normal picture would look like this picture above, but it's like I punched it from the top and I punched it from the bottom, and those pieces caved in. Okay, you can just Google concave, convex if you want to get some more pictures for that. Alright, the next suckers say we got to figure out whether it's scalene, isosceles, or equilateral. Okay, scalene means all sides are different. Isosceles means two sides are the same. Equilateral means three sides are the same. So let's go through our pictures. Number 5. They all have these little single tick marks, which means all those sides are equal. So equilateral. Okay, number 6. How many sides are equal? These suckers with the double tick marks are the same. And those are two sides are the same, so that means isosceles. The last sucker, if you look, the hypotenuse has one tick mark, then there's two tick marks on another side and 3 on another. That means all 3 are different. So scaling. Okay, next. Let's look at these tick marks. We have 1 tick mark, 2, 3. Okay, so if the sides were the same, they'd have the same tick marks. Like for example, this isosceles had the double tick on both sides. That's how we knew those sides were the same. Here we don't have any, so it's scaling. And those questions were repetitive, 5 through 7. So your test will only probably have 1 of those. Okay, the next sucker is talking about symmetry. It says, does the figure have line symmetry? That's like a line. Yeah, okay. Then it says, does the figure have rotational symmetry? And then the last one says point symmetry. Okay, rotational means you can turn it any amount and you have the same picture. Point symmetry means you can only turn it half a circle or 180 degrees and you get the same picture. Okay, so let's see here. First, does this sucker have line symmetry? Yes, it does, because I could cut it down the side. I could cut it down the middle and it could fold. Or I could cut it up and down and it could fold. Okay, so this is my, oh, you can't see that. Okay. This is my shape, okay? And I can cut it down the middle. I can fold it down the middle and it'll be symmetric. Or I could fold it left to right and it'll be symmetric. So left to right, top to bottom. Does it have line symmetry? Heck yes it does. Because I can split it down the middles, or I could even split it crooked if I want. Okay, anyway, let's go to rotational symmetry. Rotational symmetry means you can turn it any amount. Okay, so let's hold it down in the middle and spin it in a circle. How many degrees will I go through? Okay, I'm still spinning it as a circle, and I want my picture to be exactly like this black little pill looking thing. So I'm still spinning it. Hey, I got the exact same picture. So let's go over this again. You hold it down the middle, and the question is, can you spin it partially or however much to get the exact same black pill? So let's see. This is my pill, and I'm gonna spin it in a circle, and hey, I only spinned it half a circle and I got the same picture back. So here's your pill, and you spin it halfway around a circle and I get the exact same picture back. Okay, so we did like a half turn and got the exact same picture back. So that means yes, it has rotational symmetry. Okay, we specifically did half a circle, but sometimes your picture could just turn a fourth of a circle. Point symmetry means